Welcome back, everybody. Today we're going to continue on, and we already talked about the schedule, and everybody's here, so the talking on the video is like pointless at this point. However, we are going to look at stuff. So we live in Unalaska. Big school, small school here. Have you been to bigger schools? Okay, so this is pretty close to my largest class. I have a class of 19 and I have a class of 20. During the first week, my smallest class was 3, which is insane. Like, that was super tiny. But they're kind of leveling out at this point. So we're going to make a bar graph real quick, and I'm going to try to be as concise as possible with the writing it down, with the understanding that y'all are paying attention and listening, so that maybe we don't have to write every single thing down. So let's say we're at a bigger school. Has anybody gone to a larger school than this, like to study at that school? Okay, so you went to a bigger school? Where? Okay, so when it was Vancouver, right?
Yeah.
Okay, how big were your classes? Do you recall, roughly?
Like 80.
Like as a freshman class, you mean, or a whatever class?
Elementary school.
Okay, so that is much larger than here, obviously, but not necessarily what I would consider a large class. Anybody go to a different school where, like, in a singular class, you had more people than this? You've been to somewhere bigger?
Yeah.
Okay, so I have friends that teach. It's weird, like, 2 of my best friends growing up, we are very different people, but one of them's a math teacher, and one of them's a science teacher, and I'm, like, right in the in-between with them, which is kind of cool. So we're going to make a bar graph, and we're going to consider students or classes, we'll just simplify. And this is going to serve as the title of our graph. So we're going to make a bar graph. We're going to include the title just like we did. Classes at, and let's say, we'll say RCHS. Now, I'm from where? South Dakota. Do you know anything about South Dakota? Mount Rushmore. That's one of the 2 things you might know. I guess we could probably deduce another one. It is south of which state? North Dakota. Okay, so that's not like crazy or anything. Mount Rushmore's there. Anything else you know about South Dakota? Okay, that's fair. There's not a ton to know about it. There's a lot of indigenous peoples. Where I grew up, it was split between people who look like me and then indigenous Lakota Sioux students. Beyond that, can you name a city in South Dakota? You guys are in geography. What's the capital? Okay, nobody in South Dakota.
Thinking about it for like 2 minutes.
Nobody in South Dakota is cultured enough to say Pierre, because it's obviously named from which language? French. It's French, right? Pierre is a name in France. Okay, Pier, South Dakota, like the pier of like a bay. Like that's how we say it where I'm from. Anyway. Pierre's the capital. It's not very large. It's actually really small, like 10,000 people. It's not very big. It's weird because it's right on the division between Central Time and Mountain Time. So in half the city is an hour ahead of the other, and it's silly that they would do that. Any other cities you can name? Okay, that's fair. Sioux Falls is the biggest city. It's on the very eastern side of the state. And then Rapid City is close to where I'm from. And it's a pretty big city, not like huge, but like 100,000 people at this point. So let's pretend that one of us or me or whomever, we're looking at a teacher at one of the high schools in Rapid City. And we're just going to make a small table. I'm going to look at the hour of the day that they teach, and we're going to make this up. This data is not real, just so you're aware. And number of students. And we're going to construct a small table for this. Now, is it possible that we could reach out and like get real data? Yes, I don't think we need to, nor do I really want to, but we could. Okay, I have no idea what their schedules look like. Some schools have 8 hours in a day, some have 7, some have 6. It just depends on where you're at and how long the hour is. To make it simple, let's say there's just 6, just like us. And we're going to say that these are larger classes than we have here. So they have 6 hours throughout the day. All right. As I'm looking at this data, let's make up some numbers. Big classes. So I don't care what it is. I'm going to pick 6 random people, and you're just going to shout out a number that you may expect to actually find in a class. Just to check, do you think you're ever going to find 100 people in a high school class? Yes. You shouldn't. You should never find that many people in a high school class. In an introductory college class, I've taken classes with like 300 or 400 people in it. but it's less of a class and more of a, you just go and listen. Like, it's not conversation, it's not asking questions and interacting like this by any means. It's just you go and listen to a lecture for an hour and then you leave. Okay, so no right or wrong answers as long as they're not like ridiculously large. Number 16, is that one person who's here? I don't know numbers, I don't have my sheet. Is 16 occupied? Who is it? Vincent, right? Because we moved somebody else to 10. You're 16, right? Okay. Give me a number between, let's say, 10 and 45. 34? All right. Number 9. I'm going to switch color. You probably can't. Give me a different number.
45.
Okay, so a big class. All right, number 12. Hit it.
40.
40, okay. Number, geez, we're getting the same numbers over and over. Number 8, that is Chelsea.
30.
30, okay. Number 6, give me a number.
25.
25. And we'll get one more. Last person, number 3.
43.
43. Okay. Now, hypothetically, and this is kind of subjective, if you were in classes of this size, which one do you think you're going to have the best learning happen in?
25.
Probably 25, because even in a class of 20, sometimes you probably have classmates who are talking and distracting you and stuff. In a class of 45, I can't imagine teaching it. It would be awful. Okay, so if I were to graph this data, couple things, and if I'm talking about stuff that occurred in other classes, I try my best to keep them separate, but they all kind of run together for me. Which of those is independent variable, do you think? So independent, remember, is the one that we change or manipulate, or the one that influence the other. Is 34 students determined by the fact that it happens in first hour? Or do you think 34 students, that number determines that it's first hour?
34.
It's a weird question. This is a weird situation.
Hours independent.
Time is 99% of the time, didn't mean to be repetitive. It's mostly going to be independent, which is which axis? X-axis. So we're going to make our graph here, and we're making what kind of graph based on the name of this section? Bar graph. So do I ever need to have negative numbers? No, a negative number class would be super weird. So I have graph paper, you don't, or you might. Do I expect you all to pick up a straight edge as you're doing this? No, I wouldn't do that. Okay, so we have our scale set up, and I have a label. It's just not centered. We're talking about classes at RCHS for whatever teacher. Rapid City High School, by the way, is what RC would stand for. Now, when you were making a graph, yesterday I think I drew one that kind of bugged people. When I'm assigning values along the x-axis or the independent axis, should I stay consistent? Okay, so this is where it gets weird. If I wanted to, and since I have graph paper, and you probably don't, could I go through and mark 1, 2, 3, 4, 5, 6, just like that? Now, if I'm only going to do 1 through 6, does the scale that I've picked make sense to you? You hate it, I think.
I do.
Why?
There's more space. You can just
Oh my gosh, it's so annoying. Look at all this leftover space. Now, to fix that, easy to do. I'm not really going to count, although these are groups of 5, so I can. There's 15 here. If I let 2 at a time represent 1 hour, that seems reasonable. Okay, so there's 1. If I don't want to label it. What dash does that indicate? 2, and I will label it just to be consistent. Here's 3, 4, and 5. And 6 rather. Does your graph have to be exactly the same as mine? Does anybody have graph paper?
Yes.
Okay, if you're using graph paper, cool. If you're not, also cool. I don't like the idea of waiting, especially if just during a lecture, but in every single one of your desks, there should be a straight edge. Specifically a protractor. Please don't take it if it's in there. Is there not in there? Okay, yep. If you want it, everybody has a straight edge if you want to use it. I'm not going to require that you do. Saw that coming a mile away. Okay. So I have classes in hours 1 through 6 labeled there. Please don't take those. We use them in other classes. Am I done with my independent or my x-axis right now? What else does it need? Hour, right? We need to have some sort of label. So I'm just going to write hour down here. Okay. Now, here's the other part that people often struggle with. You guys have done a bit of graphing, right? Like, maybe not crazy graphs, but when you graph, just out of curiosity, how many of you guys regularly, especially in a math class, just do the 10 by 10 and you draw right down the middle like this? Anybody do that? Like, if I asked you to graph in algebra without looking at something, how many of you would make it so it looks just like this and you see everything? Okay. Why?
Bigger scale. See further. More FOV.
What if my graph is just here? Did I really need all that? I would encourage you to think about it, but I'm not teaching you math, so it's just a discussion. Okay, on my y-axis, my dependent axis on this situation, I can see that I can jump 15 times. What should I make each thing represent then? Now, I have 15 only because I can count it. You may or may not have a scale. I need to start at 0 if I want to, or is there a way that I can make it so that, like, if I just count by ones, 30, 25 doesn't show up until way up here, right? How do I show some sort of skip is going to happen? What can we do to our graph? You could go by 5, but still, even if I go by 5, I'm not going to have to use anything until I get right here, and this whole region's just not used. Is there anything I can put along this axis right here to show that I'm jumping to some numbers? So you could put a scale. Have you guys ever seen this on a graph? So I'm going to try to fix that so it looks a little nicer. Okay, that will show up pretty frequently in the world of science. That tells me that I have condensed this down. So I still start at 0, 0, but I don't have to go all the way up to 25 just to start there. I can say that within this little thing, I've already jumped as many units as I needed. What I want us to do with that then is, this is the first number I care about. I know I need to see at least 25, and at most how big? 45. So I don't care what we jump by. I think if I jump by 5, it's too much. If I mark this as 20, and I do a dash, let's say every 2, just so it's kind of consistent. And I'm taking the time to dash these out. What do you want me to jump by each dash? So if I jump by 10, like, it's not a terrible idea, but check it out. If I were to jump by 10, and I'll write this in red before I commit, that would be 30 and 40 and 50. And because I've already drawn my axes, all of this now is wasted, and I don't need it. If I jump by 5, I'm just going to think this out. I would have 20, 25, 30, 35, 40, 45, and 50. 5 would be a good number to jump by here. I'm going to commit to that. So 20 and 25. Do I really have to label every single one? No. In fact, oftentimes I won't. I do, however, want to make sure I have at least 2 of them so I can pick out the scale. So just like down here, I knew this gap was 1 hour. I'm going to make a scale here. So maybe I skip to here and say, oh yeah, there's 35, there's 45, and then I can reason out what these middle ticks wind up representing. Does that part make sense? All right. So I'm just going to plot the data. And I'm sure I've asked this before, and I'm sure I'll ask it again. Anybody in here colorblind that you're aware of yet? Okay. So I'm going to try to stay consistent with the colors. And I'm just going to plot, some points. At 1, I have 34. And I'm not going to take time to do this perfectly, but would you believe it if I told you that was 34?
Yeah.
Okay. So at 2, along the x-axis, or the independent axis, I'm going to go up to what number on the y-axis? At 2, I'm going up to 45. So let's see, I think it's right here. Okay, at 3 on the x-axis, I go up to where? 40, which I think is going to be right here. And I'm going to let you guys do this, and I'm just going to do it without talking about it every single time. I'll give you a second. Plot your points. They don't have to be perfect, but they shouldn't be like wildly far off. Cool. All right. As we look at this, then, first question: should I connect them?
No.
No.
Why not?
You're not gonna have this.
Say that again.
You're not gonna have this at any point.
Yeah, I'm never gonna have 1 1/3 hour. That doesn't make sense. Right now, do I have a bar graph?
No.
I don't think so. Not yet. Anybody recognize that graph that we have there? A dot plot, or not what I learned it as, but you're absolutely right. A dot plot or a scatter plot. Okay. You guys all use the word dot plot?
I think so.
I used scatter plot when I learned it, but they're the same thing. Now, if I just needed to represent the data that we've collected, will that suffice? Is that enough to really show it?
Yeah, that's right.
Could we make it better and easier to read, though? Now, if I don't connect them, that means it's not continuous. And I agree, we shouldn't connect them. What's the word that we use for not continuous, though? Discrete. Okay, I'm never going to judge your artistic ability, but if we take the time and I have like a computer to do this with, I can make this graph like 1,000,000 times easier to read. It might be kind of annoying. I'm not going to fix it, just for the record. If we add these guys and we take a second, and you guys don't have to color like beautifully or anything, but if I add these, does it make this graph easier to read and to make sense of and for us all to get conclusions from? Okay. Are there situations where this would be dumb? Any situation where it wouldn't make sense to use this?
Let's see, like a black and white piece of paper, black and white.
So certainly if you're just using black and white, like if you're limited by like the technology that you can use to print it and stuff, huge issues there. If we had continuous data, would you ever want to use this sort of graph? No. Okay. Follow-up question. We did this purely because a couple of people said, yeah, we should probably review it, which I'm fine with. If I give you data and say, hey, make me a scatter plot by hand, quick check, and I'm like, just full honesty, there's no right or wrong. Thumbs up says that, yeah, I could make my own bar graph if you give me the data. Thumbs down says, I've been zoning out for the last 3 days. What the heck is a bar graph? And anywhere in between. You don't have to broadcast it out to everybody, because I get that if you're not comfortable with it, nobody wants to say, I don't get it. That's a hard thing to do. Okay, so it's going to drive me absolutely bonkers if I don't finish it. So bear with me for just a moment, and I will finish this one. If you ever want to get like super creative with stuff in here, first off, you do not have to, unless I give you an art assignment, which it could happen. But the second part of that is back on the counter behind the blackboard or the door, yeah, whatever you want to call it. There are colored pencils and markers and stuff that you guys are welcome to use to borrow if you need. Is this a lot easier to read? What's the biggest class? What hour? 2. What's the smallest? 5. What's the average? I'm just kidding. It's not there, right? We don't have the average written on this board. Trick question. Could you find it?
Yeah, the mean.
How do you find the mean?
I calculate for me. Add all together and divide by 2.
Oh, by 2.
Maybe that's how it works.
Okay. You would add these up and divide by 6. What if we wanted the standard deviation? Okay. All right. Look at that. All right. Cool. You think I might make you make bar graphs?
Yes.
I bet I do. I'm trying to remember if it happens on the homework or not today. How many of you guys have used Excel or Microsoft Sheets to do graphs and stuff for you? Okay. I will teach you again how to do it because turns out I don't love the Google version. Like formatting a Microsoft Word is a pain in the butt. Formatting a Microsoft Sheets or whatever their Word document is, it's awful. Like Microsoft becomes user-friendly, which is like a terrible thing to say because it's awful. Okay, so we've looked at 2 different types of graphs. We have looked at line graphs, right? We looked at those yesterday, and we saw one that specifically represents motion. We've looked at continuous line graphs. We saw a discrete scatter graph, or a dot plot is I guess what you guys call them, or a bar graph. Any other kinds? Now, there's one more that we talked about yesterday, which I didn't have a good way to represent it. Maybe this is better. Okay, yeah, I don't know how to do that. Now, would a pie chart make sense for this?
Yeah.
Now, right now, would a pie chart give me the exact same information or different information? It would be the same info overall, right? But it'd be something very different that we'd be concluding from it, and it depends on what you're trying to like get a point or get across with your graphic that you're using. What percentage of my class right now, or of my students, are in 5th hour? Do you guys know that answer?
5th hours?
Yeah, in this one. You would have to add it all together and then say 25 out of however many, and then you get a percentage, and then you have to multiply it by 100 to get the actual percentage, right?
Oh, yeah.
And it's kind of a mess. I have a fact, I'm not going to call it a fun fact because I can't promise. I have a fact for you though, real quick. Why percent? Like we use this symbol all the time. If I wanted you to write 13% as a decimal, do you know how? 0.13. So you all know to move the decimal 2 to the left, I imagine. Why? Okay, per means divide. Now, cent doesn't really mean anything just on its own. How long is a century? 100 years. Literally, percent is short for per century out of 100, which tells us move the decimal 2 to the left. Because it's 10 to the negative 2, but we're getting math here. Is there anything about my graph right here that I would not get full credit for?
Labels.
Where?
For the hours. Oh, if you're just looking at the bar graph,
Mm-hmm.
you're forgetting the students.
I need labels. Number of students. Okay, and then realistically, I wouldn't encourage you guys to do this, but because I'm on, a computer, I would put the label there because it'd be less annoying. You don't have to move yours. Okay, we bless you. Okay, we don't bless you, but all right, maybe we do. I don't know. I'm not speaking for everybody. Bar graphs, line graphs. We're gonna look one more time. It's gonna get a skosh of mathy for a second. Because we're going to look at circle graphs or circle chart or pie chart or whatever you call them. So, last little thing here. Do you guys need a second to finish writing here?
Yes.
Are you writing? Where's your, okay.
Wait, what is standard
You,
deviation?
What?
I asked if you needed more time.
Oh.
And you said yes, but you're not writing or anything. So, standard deviation is how far from the norm are you? Now, so it can mean a lot of stuff. On average, 68% of people fall within one standard deviation away from the average. So, like, what's the average grade supposed to be? A C. Now, I would say a middle of the road C, like 75 is what I shoot for with my tests and quizzes, just so you know. There's going to be most people, if we have a true test that's written well, most people will be pretty close to a C, whether it's a B minus or a D plus. 64% of people will fall there. There will be a smaller number of people who get B minus to an A or to a D minus. And then you'll have the extremes where you would have like way fewer people get A's or F's. And that's how it should work. Standard deviation is just to tell how far above or below the standard you are based on like the population.
Is that the graph when you have like a curve?
It's the bell curve, if you guys have ever seen it. I don't know if you have seen the bell curve or not. I don't know where you would. Okay, so we looked at those graphs. One more little thing to knock out, and then I'm going to give you guys some time to work and maybe, hopefully, start our next section. Okay, the last thing that we're going to look at in here. Circle graphs, pie charts, circle chart. How do you want me to refer to it? I prefer pie chart. Just a heads up, your book, and I'm going to go ahead and write this out as a vocab. Your book calls these circle graphs, just so you know. Now, when people make pie charts or circle graphs, whatever you want to call them, people regularly overlook something that's super important because with decimals, you wind up getting like little parts of the whole, and if somebody messes up rounding once, it destroys the pie chart and it doesn't make sense anymore. So, in its most basic, we're just going to get a definition. A pie chart is used to show how components break into different parts. And I can spell, I promise. Is components a word you know? Okay. The parts, right? how components, and I'm going to reword that, represent the whole with a W-O-H-O-L-E. Represent the whole. Okay. Now, for this, that's the source of heat. I'm going to use your book's data, which I don't always do. But like, I'd like to do people, but I don't want to Google stuff necessarily. Did I tell you guys that the tech guy came up to me and told me I was number 2 out of nowhere? He just said, hey, you were ranked number 2 this week. And that's my initial question. So we have a thing that tracks productivity, specifically on the computers. And apparently there's only one other person in the entire school, students or staff, that visited more websites than me last week, which I thought was crazy because I don't visit many websites throughout the day. I don't know why. I don't know who beat me. It was a student that beat me. I don't know. He told me I went to 500 something websites last week, which I don't think I did. But I do play a lot of music, and if it's on a playlist, each little thing is its own website. So my guess is that's where it came from. Anywho, okay. Couple important things that we want to make sure happen here. What is the whole amount of something? Okay, so it's all of it. The whole amount. Give me a percentage.
25.
Ooh, 25% is the whole?
Oh, 100.
100% of it, right? 100 per century, or 100 out of 100. Okay. What does percent symbol look like when you draw it?
Slash, circle, circle.
Do you guys take the time to circle/circle?
Yes.
Okay. Just so you know, I draw them like this.
Like a 7.
That's pretty much a 7 because I'm lazy. Okay. If you ever can't tell what I'm writing, that does not say 107 or 1007. It says 100%. Okay. The whole amount is 100%. As you break this up, what should all the component pieces of your pie chart add up to then? Everything must add up to 100. Is there a shorter way to say add up to? Good. Everything sums to 100%. Now, you have to pay careful attention when you're doing it because inevitably you will get goofed up on the rounding. And if we have a situation where we use a pie chart and I see that your pie chart only adds up to 99%, you won't get full credit. Just a heads up. Okay. How do you work out a percent?
Find a fraction.
You find a fraction, which we all love fractions, right? Okay. Are you good with fractions?
Yeah.
Okay. Can you convert between fractions and decimals? Pretty easy. Okay. 1/2 is what percent?
0.5.
Boom. 0.5 or 50%. Cool. What about 1/3?
33%.
Just 33? Exactly 33?
33.3 repeating.
33.3 repeating percent, right? What about a 4th? 25%. A 5th? 20? Yeah, 20. Okay. A 6th? 6 times 12 is definitely 74. 6 times 4 is 24. 6 times 17 is 60 plus 42 is 102. That's too big. It's going to be 16 and a decimal that I don't know off the top of my head. Love what Liam's doing. Liam doesn't want to hear us just guess and kind of throw it around. Liam, what is a 6th? 16.67 or 33? 16.6666 repeating. Okay. Now, there's situations where you can do it really easily or not. Are you allowed to use calculators?
Yes.
100%. I am not testing your mental math ability. I'm testing your ability to work through problems. So, we're going to make up, and I'm just going to trust their figure. For whatever region, I'm going to ask you guys to make a pie chart. Do I expect you to draw perfect circles? No. Okay, so here's what I want you to do. Make a pie chart. All right, and anybody in here like hate pie? You don't eat pie?
No, pumpkin pie.
So you don't like pumpkin pie? Oh, you do like pumpkin pie. So I'm not, notice, no specific kind of pie. All right, let's pick here real quick. We're going to make a pie chart about pie because that seems appropriate. Cool. All right, how many people are in here?
19.
I think it's 19. Do I count as a person?
Yeah.
Okay, we'll say 20. Okay, we have 20 people. So check this out. We aren't gonna list like a ton of them. Types of pie.
Oh yeah.
And the number favorited. Okay, I'm not gonna go through like a million different types of pie, which would be absurd. 20 types of pie is the maximum that we would hit in here. But we're just gonna use like common flavors that you might find.
Apple.
Give me a flavor.
Apple.
Pumpkin. So we got pumpkin.
Chicken.
Yes. Leave your phone, okay? Ooh, pot pies. I don't think should count because I'm looking at desserts. Okay, so banana.
Apple.
Apple.
Strawberry. Cherry.
Strawberry and cherry. Okay. Some more what?
Is that a thing?
Some more what? All right. Okay. There exists more pies than this, obviously. Real quick, we're just going to take a quick survey. Of these, which is your favorite? And instead of just shouting it out, because I'm never going to be able to organize that, who's going to count for me? I don't know how to count. All right. You two together, you're going to count these values, okay? Who out of those 5 flavors prefers pumpkin? Leave them up. We need to count. 9. Okay. Okay. Who prefers banana cream pie? 3. Okay, got it. Who prefers apple?
Okay, so Chelsea's gonna put everyone.
Strawberry pie? You're strawberry? You're apple. Okay. Did I count you with apple? 2 for strawberry. We're going to find out if we have an error or not. Who prefers cherry pie? Okay, and I don't know Sabrine's answer, but I'm going to pretend that she preferred cherry. Okay, so if I want to take this data and make a pie chart, I'm stuck. I don't know what to do. Kevin, I haven't called on you today. There's a lot of you that I haven't called on. I'm going to be more mindful of that. How would you start to even think about a pie chart here?
Draw a circle.
So that's a good idea. We'll get there, but I'm going to let Kevin continue. Before we draw the circle, maybe.
Like, break it down to the base as well.
You could rearrange it. I'll tell you, I'm lazy. I would rather not have to rearrange it, but it's a good idea. You can. Somebody else that I haven't called on today, let's see. Riley, and we're going to do this another way because maybe you're not quite sure. I'm going to give you like 30 seconds. Chat with people around you so that you have an idea to answer if I call on you. Pie chart discussion. And I want to start making a pie chart. After your discussion, somebody give me somewhere to start. All right, I'm gonna let you go, Sonny, just because I called you Liam.
Try to find the percentage for the numbers.
Okay, how do I find the percentage of what 9 is? How on earth would you do that? So you're on the right track, but you gotta do something else first. 9 out of 20, right? Like we need that first. Okay, so before we do anything, we need to check to see if maybe in our measurement we have an error. There's 20 people in this room. There's 19 right now, but we'll have 20 in a second. 9 and 3 makes
12.
and 4 is 18, 20. Okay, so I'm confident with that. I have a total number here. There's 20 total. And I'm just going to write this down so I have it somewhere. Now, does the number 9 ever have to show up on my pie chart? No, like I'm never going to see 9 unless I want to include that information to show how large of a group I was looking at. If I want to figure out how much percentage something is, I'm going to make an arrow so that doesn't look like a fraction. Those all add up to 20. Okay. Either in your calculator or in your head, do you know what 1/20th is? Like as a percentage? 5. You have 9 of them. Okay, we have an option. I'm going to represent this. I'm going to add stuff to this. Do you want me to write 45% or 0.45? Okay, 45% of the class prefers pumpkin out of these flavors. Did I lose anybody just now on how I did that calculation?
Oh, so like 9 over 20?
9 over 20 is all I did. Yep. Now I did it with mental math because not everybody has a calculator in front of them. I know that 1 out of 20 is 5. 1/20th or 20%. I'm sorry. 1 out of 20 is 5. Yeah.
So we just put every like number of favorites over 20? 'Cause
Yep.
That's the total?
Absolutely. So I guarantee this one's going to be 15%. And I'm going to challenge you guys either mental math or using the calculator in your desk or your algebra calculator if you happen to have it. Please don't take the ones out of my desk, and if you do, bring it back. You'll notice it eventually. Give me my percentages.
You got 40%, and then you got 10%.
4 should be 20%. Yep. So check this out. When we type this into the calculator, it doesn't say 20%, it says 0.2. Remind me, percent means divided by 100. To undo a divide by 100, you would multiply by what? If you take this number and you multiply by 100, what does it become? 20%. The number would be 20, and we would just call it percent. Cool. Because 100%, the whole is just one whole, and we just use 1, and that's why the decimals come out. Okay, 2 out of 20, how many? 10. And the last? Also 10. Okay, is there anything that I should check before I commit to making this graph? Okay, so 45 and 15. And 20? And 10? And 10? Okay, so did we get the whole? Okay, so we got 100%. I'm feeling pretty good about this. Now, here's the challenge. I don't care, especially if you're drawing them by hand. I'm not going to give you guys like a compass to draw a perfect circle. I, however, can draw a perfect circle. You ready? Hey, there's my perfect circle that I constructed, and for whatever reason, it took away my grids. I don't know why that happened. All right, so here we are. Am I going to take the time to grab my protractor and measure actual angles?
No.
Could you? Ooh, you think mathematically you know how to do it? What's 45% of a circle, and how would you measure that if I asked you to do it like mathematically?
45%. That's like half.
Yes.
Or
Like
less than half?
So a little less than half is really precise in mathematics. And I'm going to pause real quick. Miss Begley, can I help you find somebody?
I am looking for
Gian. Oh! I don't know what's going on.
I don't want you to leave. I'm just kidding.
I'm gonna read it to the class. That wasn't just kidding. It's none of my business. I'm messing with you. All right. Now, if anybody's interested, we can talk about it. I'm not gonna make us do it ever because we're not gonna use protractors right now. How many? When you talk about this amount of rotation, you ready? You gotta check it out. How much did I just rotate?
270.
What? Where did I start? I'm gonna start here.
Yeah.
360
Okay. First off, 360 what?
degrees.
What's 50% of that number?
180.
Could you find me 45% of that number and get a degree out of it? I bet you can. If I ask my calculator what's 45% of 360, it would say, oh, Holloway, use your protractor, measure an angle that's 162 degrees. Am I going to do that? I'm not going to. You can. I won't. So, can we reasonably estimate it? Okay, so check it out. I, first of all, need not an eraser. Okay, I'm going to start right here. If I go to right here, what percent would you estimate I'm at currently?
90.
So that's at 90 degree. Careful. Right now, 25. How about here? 50, and it's really going to bug me because I'm opposite of it. So we're going to try that again without moving it. That'd be 50% of the circle, right? Do I need more or less? Could I go this way to make less?
Yes, you could. Yes, you could. Yes.
I could, right? Like, it's weird because everybody might want me to go that way because of the way I was rotating, but either one would work. Okay, if I want to indicate that, hey, this part of your circle, and we'll see if it works. Love it. I'm really surprised that worked just now. What percentage of the circle is that? 45%, and of that 45%, what was the flavor? Pumpkin. Okay. I don't expect you guys to have perfect circles. Here's my challenge for you. Did I spell it right? I did. Okay. I'm going to give you guys a minute. They can be awful circles. But I want you to estimate these. You do not have to shade your regions. I'm going to give you a minute. I want you to make the pie chart for this pie data. Cool. What are we doing right now? You're making this pie chart. I've done the 45%. It's your job to roughly estimate the other ones. I'm going to give us a minute. Let's say we had 10, and people tend to go in order, and I get it. I'll label these afterward. 10% was supposed to be strawberry. That means that we had another one that was 15, and another one that was 20, and another one that was 10. Okay. Anything annoy you about the numbers I've just assigned?
Yes.
What? Yeah, there's no reason that this 10 should be way larger than the 15%. Right, Carson? What did I say?
The 15% is smaller than the 10%.
Okay, you got me good. I did not think you were going to catch that. Now, in reality, does the order that you write them down matter here? No, but I'll tell you, when I did this, if I knew this was 45%, when I drew this first one, I went here because I know that this is how much of the circle roughly?
Like 5.
That'd be 5. So all I did is I took that and I doubled it to get to my 10, and now I have a good approximation of it. Realistically, 10%. 10%. What do you think this one is?
20?
I can't really tell. That looks like 20 to me. And again, I'm not going to measure the angles. If this annoys you, I can fix it a little bit. Maybe that one's 15. All right, is it annoying you?
They look the exact same.
That's more annoying. Did you see the grid paper showed back up? Okay. So we'll get it, don't worry. Okay, 15 needs to be bigger or smaller? Would that, so you think so? That would just make the 15 smaller, so maybe it's just a point of view sort of thing. Oh no. That a little bit better? Okay. Now, what else should I have?
The color.
I'm not going to color it. The labels. Now, Riley, I love your idea, and I'm going to steal it, and I'm going to use it. Some of you drew circles that were too small to write all the words in. Is it clear if I just do this? What do you think A stands for? Apple. 10 and 10 were strawberry and cherry. S and C. And then banana right here. Okay. If you color it, it'll look nicer, but it's certainly not a requirement. Now, we have our percentages. Here's what I want you to do. We're not going to start a new lesson. That went longer than I was expecting it to. Tonight, though, you do get some homework. You don't have homework. You get homework. So, I will link the video here in a minute. When people are here, I don't know that there's a lot of value in posting the video, but if I talk fast or you miss something. Okay, homework tonight. You get homework 1.3, which you will find on page 23, and you get to work problems 12 through 16. This will be due tomorrow at the start of class, which means if you need to ask questions, I'm available after school, at lunch, or before school. You just leave it there. I'll grab it.
Why'd you start counting with me?
All right, later Raiders.